Okay, so you're going to be given a lab test. It's very similar to the lab you did, right? So we have some mixture that we need to separate. So it's not going to be these same chemicals, but I'm going to kind of guide you through how you figure it out, right? So you all should have seen this by now with the lab, so this will help you if you weren't paying attention or if you're absent. I really recommend you pay attention to this video. So if we've given these 4 chemicals to separate, we've learned various techniques to separate them, right? So one of those techniques is pulling them out with magnetism. One of those techniques is to boil water away, right, by looking at the different boiling points. One of them is to float them up with density, and one of them is to get them into the water in the first place by dissolving them. So I know from my notes and from my lab that I want to do the magnetic step first because I don't want to get my iron wet, right? It's just an easy thing to do first. There's no reason to hold off and do this second or third or fourth. There's just no reason for it. It's always going to be the most efficient thing to do first, right? Even if we're not using iron powder, even if we're using something else that doesn't matter if it gets wet, it's just easier to do this at the beginning. There's no reason not to do it. And then once we do that, right, we'll be left with our other things. So I would cross this out. So one thing I would write is I'm going to do my magnetic step first because it's easy to do and it'll get it out without getting it wet. That's what I would write down. So then what's the next step? Okay, so I've got my iron out. I don't need to worry about this anymore. So now I have salt, sesame seeds, and sand. Well, I know that one of the things I need to do is separate things out with density by getting it to float, and I need something to dissolve in water to separate that, and then I can filter them as well, right? So my next thing that I notice is I'm looking at the densities here, and I notice that if I add some water to this mixture, there's only one thing that has a lower density than water, and that'll be the thing that floats, right? So this is what I'm looking for. And when I describe the step and try to say which one floats, it's very easy. I'm just looking for the one with less density than water, right? So I'll be able to say the sesame seeds will float to the top. So my second step that I want to do is to float my sesame seeds up and scoop them out with a filter. Now, one thing I need to add is that I don't want any of my salt to get on my sesame seeds. Since the salt dissolves in water, as I scoop out my sesame seeds, I want to talk about how I'm going to rinse them off with some distilled water so that my salt stays in my solution and only my sesame seeds get separated out, okay? So that would be my second step. Now my sesame seeds are gone, and so I've only got 2 things left. So I've done 2 steps now, right? Separated by magnetism and then separated by density. So next I have sand and salt, sand and salt. So I know that my salt now is dissolved in water because it dissolves in water. And I know that my sand is not. So I know that I have some very, very, very tiny salt particles. Anything that dissolves in water becomes incredibly small, just very, very small. Sand doesn't though, so it's still going to be big particles. So at this point, what I can do to separate my salt water from my sand is to run it through a filter paper. When I run it through a filter paper, my salt will go through with my water into the tiny, tiny holes of the filter paper, whereas my sand will stay right on top. Now, I know in this step, one thing I want to mention is that my sand's going to be wet as the water runs through the filter paper. My sand will still be wet, and some of that water will still have some of my salt in it. So I want to give this a spray with my distilled water to push this salt through the filter. Now, once I do that, my sand will just be on top of my filter paper, and I can just collect my sand and set it to the side. So my sand is gone. So all that's left now, right, is my salt and water. Okay, so I need dry salt. So what's left is I can look at the boiling point. Okay, so by the way, that step was filtration, right? So I filtered it out because the salt can fit through the filter paper when it's dissolved, but the sand won't. And then my last step then is I want to boil and distill what's left. I look at the boiling point of salt, it's very, very high, very, very high, thousands of degrees. Water's only 100. So if I set my saltwater beaker or flask on a hot plate or a Bunsen burner, all of the water is going to boil really quickly, but the salt's not. So it's just going to stay, and then I can just scrape it up at the end. So my last step that I'm looking at for these substances is which one will boil away. Okay, my water has a very low boiling point, so it'll boil away very quickly. My salt will be left behind, and now my mixture is all separated. Okay, so I'm using distillation and boiling point for the last step. So if you noticed as I was going through, right, I didn't just pick random steps for random chemicals. I used the chart. This is going to tell me which one's magnetic. This one's going to tell me which one I can dissolve in water to filter it. This one's going to tell me which one will float to the top that I can separate out for density. This one's going to tell me what chemical will stay in if I boil it, right? Will my water leave? And which one will stay in. So all of these resources you need to pay attention to, right? Because it's not going to be iron, salt, sesame seeds, and sand. It's going to be 4 different chemicals, but I'll give you this data table, and now you know how to use it to come up with a procedure to separate these 4 things out. Okay.